is Alex Grashoff, and I'm the Group 2 leader for this week, and I'll be talking about the steam injector experiment. So a brief outline to go over. I'm talking about some objectives of this experiment, a little bit of theory, why it's relevant. Kind of go over the apparatus, briefly talk on the procedures, and then show you the calculations and the conclusion. I'll give you a conclusion of what I found. So objectives, so this experiment is to calculate the steam flow rate through a choke nozzle, investigate the efficiency of the injector when used as a feed and water heater, investigate the efficiency of the injector when used as a pump, and perform an overall mass and energy balance on the injector. So a little bit of background in theory. This is a convergent divergent valve. The high steam goes in here, and the steam going through generates a low pressure because it's going at a high velocity as the diameter decreases. This low pressure causes a suction of water. It's pulling in the water and then having it mixed and ejected. This is for a subsonic jet pump. So this is when the Mach number does not reach 1. Basically saying that the velocity of the fluid traveling through it does not equal this, does not reach the speed of the C, square root of KRT. And this is a supersonic steam injector. Very similar, it has a convergent divergent valve to start off with, and then it enters a larger chamber. So the steam coming through generates low pressure in the chamber, creating a suction or pumping the water up into the entrainment, or I call it the chamber. And then it emits at a low velocity as the pressure balances out, and it causes the water to flow from a lower standpoint. So why is this relevant? Obviously, being juniors and seniors in mechanical engineering, we've had to experience a lot of pump problems and fluids or thermodynamics, and kind of really understand the importance of what a pump does. And so this is just looking at an application of a convergent divergent valve, valve or an ejector being used in principle. In this experiment in particular, we're using steam to pump water. And so it really has two major effects. Not only does it pump the water creating low pressure, but it also heats the water. And that's what you're trying to do, which oftentimes heat needs to be included. It's a great way to be efficient about it in a system. So the apparatus, you see the steam valve comes in here, the steam enters the system, and then you have two gauges, a pressure gauge and temperature gauge. The steam then enters an injector, which will, as I showed before with the injector in the previous slide, create a low pressure suction that will pull from this aquarium or tank, and then the water will mix with the steam and go through, going through another pressure and temperature gauges. These are your pressure temperature gauges for the suction water. This is the valve that will be open before the experiment starts. These are the storage tanks that I just kind of mentioned. One for the suction and one for the discharge. And this is the discharge valve. This is the delivery and suction tank discharge, so these are the valves where it will exit. And this is the flow meter and the water supply going into the suction tank. So the procedure is broken into two main parts, the initial test and the experiment. The initial test, I'm not going to read verbatim every single slide on here and every single bullet point. We're about to go over this experiment in a little bit. Just give you a general idea. It's just kind of making sure that your water is flowing properly. The injector, you kind of like balance it out, kind of play with it a little bit, make sure that you're not pumping too much water out of the suction that's going into it, or you're not pumping enough. So you want to keep the suction tank at a constant level so that the discharge is going through, making sure the valve at the bottom is closed off. And then you kind of want to not throttle it, get the steam going in, the water going through at the right pace. Once that happens, you go to the experiment. Once again, I'm not going to read every single line on here and waste y'all's time, but the general idea is we're going to set to a certain pace to where we know the pressure is going through, and the temperature is going through by gauges. And we can use these to determine, like I said, the efficiency of the system, the pump. We can determine how efficient it's heating by the steam going through. And then assuming that the ejector is choked, we'll be able to do calculations to figure out the Mach numbers and the speed. So these are my calculations. Using these 4 equations, I was able to determine what the Mach number would be, assuming it was choked. What the speed would be, using these 2 equations, the speed of the steam going through upstream, and then eventually finding the mass flow rate for the steam using this equation. I used 0.577 as indicated in the experiment, in the lab manual, and K1.4, and the area was given was 3.2 millimeter diameter, so multiplied divided by 2 for radius, squared it, multiplied times pi, and I got 8.04 millimeters squared. And my result, inclusion, the Mach number that I found, assuming a choke flow, estimated was 0.85, the velocity of the stream. And the reason it's 0.85 and not higher, because we're using supersonic, is because we're assuming to be choked. I found the Mach number upstream, so it wouldn't be above 1 before it went through the convergent divergent system. The velocity of the steam was about 330 meters per second, and the mass flow rate, I'm not positive this number is accurate. It seems kind of low, but at the same time, measuring kilograms per second through a diameter that was millimeters, I accepted it as a result, because I guess that could be possible. We're measuring kilograms of steam going through a millimeter that small, that diameter that small. Wasn't out of the realm of possibility. That's it. Any questions?
So I have a question. You are trying to test the subsonic flow or supersonic flow in this experiment?
This experiment, we will ultimately be testing the supersonic flow, because we're using in this experiment, this question was, are we testing for supersonic or subsonic? And this ejector is like the second one I showed. It's not like the first one. So we're testing for supersonic flow.
So what do you think should be changed if you want to test for the subsonic?
Can I click up here? Because I have to go through all the little. So what should be changed? Right now, this is what the design reason for the ejector is. If we wanted to test for subsonic, we should use just the convergent divergent and have the input from the water going directly into convergent divergent. Any other questions? Thank you.